Good day, dear viewers. I am still your very usual tutor, Damilare Akilude. Please do well to subscribe to my channel, Damilare Akilude, where you learn chemistry and biology. Okay, and please do well to share the videos. Also tell your colleagues to subscribe to my channel and share the videos. Okay, now let's move on. Today we shall be learning cellular respiration. Cellular or tissue or internal respiration. You see, gone are the days that we define respiration as breathing in of oxygen and breathing out of carbon dioxide. Those days are gone. In fact, it is no longer true. Respiration is defined as the process as the oxidation of glucose to generate energy. Okay, gaseous exchange is what we call breathing of oxygen and breathing out of carbon dioxide. Okay, now this equation 6,6H12O6 plus 6O2 to give you 6CO2 plus 6H2O plus 38 ATP. This summarized equation is what we have. This is a summarized equation. It goes through 10 different stages. 10 different stages catalyzed by about 9 different enzymes at each stage. 9 different enzymes at each stage. Okay, we shall start to take it bit by bit. Okay, now what do you mean by cellular respiration? I told you that cellular respiration is defined as the breakdown of glucose by a series of reactions to release carbon dioxide, water, and energy in form of ATP. This metabolic process may require the presence or absence of oxygen. Some can take place in the presence of oxygen, and another can take place in the absence of oxygen. We shall learn which does take place in the presence or in the absence of oxygen. Cellular respiration is a catabolic process. It's a catabolic process. When we say catabolism, what do we mean? Catabolism is simply referred to as breakdown of large or complex molecules to give you the simpler ones. That is catabolism. Now, they also have another term called anabolism. Anabolism is the build-up of smaller or simpler molecules to give you what? A larger one. Now, what do we know? Both catabolism and anabolism pair up to give what we call metabolism. Metabolism is the sum total of all biochemical activities taking place in the body. So respiration is a catabolic process. For example, digestion is also a catabolic process. For example, but anabolic process refers to like photosynthesis is anabolic. Where smaller particles pair up to give you a bigger one. Okay, formation of protein from amino acid is anabolic. Formation of starch from glucose is anabolic. Formation of glycogen from glucose is anabolic. So when we say catabolic process, anabolic process, you understand what the term means. So respiration is catabolic. It involves chemical activities of the cells, in which glucose is broken down by a series of reactions. Glucose is broken down by series of reactions. You break glucose down by series of reactions. A whole lot. I told you 10 different stages are involved. Okay, the energy released in form of ATP, adenosine triphosphate. Okay, is adenosine triphosphate. Okay, ATP is the form in which energy is carried out. In fact, the currency of energy in the cell is ATP. The currency of energy in the cell is ATP. Like in Nigeria, we spend naira. Okay, in Ghana, they spend cedis. So that's the currency. In the cell, the currency in the cell where communication takes place or energy is transferred is in the form of what? ATP, adenosine triphosphate. Okay, the major purpose of cellular respiration is to generate energy for various metabolic processes in all living cells of every organisms. Okay, now we move on to glycolysis and Krebs cycle. You see, these are the two major processes. These are the two processes that are involved in cellular respiration. We call it cellular respiration or tissue respiration. Cellular because it takes place in the cell. Tissue because it takes place among cells. Internal because it takes place inside the body. Okay, now what is glycolysis? Glycolysis is the combination of two words. Glyco means glucose, lysis means split. So the breakdown of glucose, the breakdown of each molecule of glucose, each glucose molecule to two molecules of pyruvic acid. Pyruvic acid is a 3-carbon molecules or 3-carbon sugar. So a 3-carbon acid. It's either a 3-carbon molecules or 3-carbon acid as a result of the addition of phosphate group to glucose. Okay, now when a phosphate group is added to glucose, you say phosphorylation of glucose. Phosphorylation on its own is defined as the addition of phosphate group to a compound. Now, this stage does not require oxygen. Glycolysis does not require oxygen. It occurs in the cytoplasm of the cell. At the end of this stage, 2 ATP is formed. At the end of this stage, 2 ATP is formed. Now, let's move on to Krebs cycle. So, in this stage, we are taking in ATP. We also took in what? Phosphate group. And in the end, we have 2 ATPs are being generated. Now, Krebs cycle. The next pathway is the breaking down of pyruvic acid into water and carbon dioxide. This requires oxygen. So, glycolysis do not require oxygen. Krebs cycle require oxygen. Glycolysis takes place in the cytoplasm. Krebs cycle takes place in the mitochondria. Okay, this requires oxygen and it takes place in the mitochondria of the cell. At the end of this stage, 36 ATP is formed. 36 ATP is formed. Okay, now types of respiration. There are 2 types of respiration, namely we have aerobic respiration and anaerobic respiration. Aerobic respiration, it is the type of respiration which requires oxygen to break down glucose into water, carbon dioxide, and energy, which is in form of what? ATP. This is the equation. C6H12O6 plus 6O2. Okay, to give you 6CO2 carbon dioxide plus 6H2O, which is water, plus 36 ATP, which is what? Energy. You see, some school of thought accepts 36 and another accepts 38. So we rather that at the end of the reaction, we have 36 to 38 ATPs that are being generated. Okay, this is a very good situation here. Okay, where the fellow breathes in oxygen, the breathes out carbon dioxide. That is gaseous state. That is breathing. Okay, now, but if the oxygen moves in there, this is the lungs, or these are the lungs, a pair of lungs. Now, it's the oxygen gets into the lungs. Blood is already there, which is deoxygenated. Oxygen mixes with the blood from in the lungs. We move the carbon dioxide, which is why we breathe out carbon dioxide. And that's the reason why the excretory product of the lungs is carbon dioxide. Okay, now when you now move on to this cell, in the mitochondria of this lung cell, okay, something happens. 36 ATP is generated. I told you that there are 2 schools of thoughts about the number of ATPs generated at the end of cellular reaction. Some school of thought, some scientists believe it is 36 and some believe it is what? 38. But for the sake of this class, we shall stand in between, but we will rather go for 36. But I will also show you instances where they also say it is what? 38. It's one of the disparities in the school of thought, in the school of science. Okay, now we have 6CO2, we have O2. Now, so mitochondria, energy is what? 36 ATP. These are the mitochondria where this is water vapor. This is water vapor generated at the end of the reaction. Okay, here is the food eaten, okay, which contains glucose, 1 molecule of glucose. It gets into it and we have 36 ATP. So for every 1 molecule of glucose that enters into the cellular respiration, going through glycolytic pathway, and Krebs cycle. In the end, we have 36 ATP produced in the mitochondria. Looking at this chart, this is glycolysis. For the purpose of this class, I will limit it to this because this is secondary school. This is for secondary school. If you are going to go for advanced or A level and also, I would have given you a more specialized form, but I will introduce you to it here. Glucose is first of all phosphorylated. That is, ATP is added. Okay, so we are from glucose to glucose phosphate. Glucose phosphate is again phosphorylated. So we have glucose 1,6-diphosphate. So 2 ATPs are used up. Now the glucose 1,2-diphosphate, then something happens. It is isomerized. It gives us fructose 1,6-diphosphate. Now fructose 1,6-diphosphate is split up, okay, by an aldolase, okay, to give you glyceraldehyde phosphate and dihydroxyacetone. Now we will continue the reaction with glyceraldehyde phosphate. From glyceraldehyde phosphate, okay, we now going to have some energy produced. We have 3-phosphoglyceride until the reaction gets to phosphoenol pyruvate and pyruvic acid. So at the end of glycolytic pathway, pyruvic acid is generated. Now the pyruvic acid, which is what? Pyruvate, is what enters the Krebs cycle. Before pyruvic acid enters into the Krebs cycle, some things takes place. It is decarboxylated. Decarboxylated means carbon dioxide is removed from it. It is dehydrogenated and it is dephosphorylated. So by the time it does that, by the time those things takes place, pyruvic acid now becomes acetyl-CoA. Acetyl-CoA. Now, so the acetyl-CoA mixes with oxaloacetic acid. The acetyl-CoA is 2 carbon because a CoA is added, and oxaloacetic acid is 4 carbon acid. So 4 carbon acid plus 2 carbon acid will give you a 6 carbon acid. So that is how we have what? A citric acid, which is why Krebs cycle can also be called citric acid cycle. Citric acid cycle. It is also called electron transport chain. Okay, it is also called citric acid cycle. It is called Krebs cycle. Okay, Krebs cycle is called Krebs cycle because that is the name of the discoverer. Okay, sorry, it is not. It is called Krebs cycles, citric acid cycle, and please take note, not electron transport chain. It is also called TCA, tricarboxylic acid. Please take notes. It is called, there are 3 names for Krebs cycle. It's either I say Krebs cycle, citric acid cycle, or tricarboxylic acid. Tricarboxylic acid. So on and on, the citric acid will be will be decarboxylated. Okay, you will have a 5-carbon molecule, which is what? Alpha ketoglutaric acid. From alpha ketoglutaric acid, it will again be decarboxylated to succinic acid, to fumaric acid, and back to oxaloacetic. So in the process, ATPs are formed, ATPs are generated, ATPs are formed. In the end, from this point, this is where some other school of thought believes that we have 38 ATPs. You see, I am making it very clear where the explanations for the 36 ATP and 38 ATPs. I am always careful of asking the question to give the sum, the actual number of ATP, because it's an issue in the school of science. So in this case, they believe that at the end of Krebs cycle alone, 36 ATPs are generated because an energy compound is involved, nicotinamide adenine dinucleotide phosphate, and reduced nicotinamide dinucleotide phosphate. FAD is involved, flavin adenine dinucleotide. Now, all these ones generate what? 2 ATP, like you will get a 3 ATP when NAD is produced. Okay, now, so in the end, you have 36 ATP from Krebs cycle and 2 ATP from glycolytic pathway. So 34 36 plus 2 gives you 38. That is a school of thought. Actually, 4 ATPs are generated in glycolytic pathway. But from what I had explained in the beginning, from glucose to glucose phosphate, an ATP is used up, borrowed outside. From glucose phosphate to fructose 1,6 diphosphate, 1 ATP again comes in. Okay, you know it was 6. Now it is 1,6, so 2 ATPs are used up. Okay, in the end, 4 ATPs are produced. So how we got these 2 is that we subtracted the 2 ATPs we borrowed outside from the 4 ATPs we eventually produced. So 4 minus 2 generates what? 2 ATPs. So that's what we have here. Okay, so this is how it goes. This is the electron transport chain here. It goes into the electrons and hydrogen coenzymes, and this takes place in the mitochondria and here in the cytoplasm. So we say TCA cycle, we say Krebs cycle, we say and Krebs cycle, because the name of the discoverer is called Krebs. Okay, now anaerobic respiration is the type of respiration which does not require the presence of oxygen to produce energy. During anaerobic respiration, glucose is broken down to yield carbon dioxide, alcohol or ethanol, and energy. Anaerobic respiration can be represented by this equation. So C6H12O6 in the absence of oxygen to give you ethanol, C2H plus 2CO2 plus 2 ATP energy. So this is ethanol. Anaerobic respiration occurs in some organisms that get their energy in the absence of oxygen. They get their energy in the absence of oxygen. For example, such organisms are certain bacteria, fungi or yeast, and in cells of plant parts, like where? Like the germinating seeds. Anaerobic respiration takes place there. In this organism, glucose is partially broken down to pyruvic acid. This acid is converted to ethanol. You know, I told you how pyruvic acid is broken down, starting from glucose to glucose 6 to glucose 1,6 to fructose 1,6, on and on like that until you get to phosphoenol pyruvate, then until you get to pyruvic acid. Pyruvic acid is a 3 carbon acid. Okay, so this acid is converted to ethanol in this case. So since the end product of anaerobic respiration is alcohol, the process is known as what? Alcoholic fermentation. So if you are asked to give the equation of alcoholic fermentation, here is it. Here is it. Okay. Now we move on to the differences between aerobic respiration and anaerobic respiration. In aerobic, oxygen is required. In anaerobic, oxygen is not required. In aerobic, byproducts are water and carbon dioxide, but in anaerobic, the byproducts are alcohol or lactic acid and carbon dioxide. In aerobic, more energy is released, that is 36 ATPs. In anaerobic, less energy is released, which is 2 ATPs. In aerobic, it takes place in the mitochondria. In anaerobic, it takes place where? In the cytoplasm. Okay. In aerobic, water is given off, but in anaerobic, alcohol is given off. Okay, but this is the alcohol given off in anaerobic here is what you have in plants. In anaerobic respiration in animal cells, it generates lactic acid. There is accumulation of lactic acid. This is the diagram of mitochondria. Here is the outer membrane, here is the matrix, here is the crystal, here is the inner membrane. You know, the production of ATP actually takes place in the matrix of the what? Of the crystal. In the matrix of the crystal. Okay. Similarity between aerobic and anaerobic. Both are involved in energy release. Both occur in plants and animal cells. Both processes require enzymes to speed up the reaction. Both give off what? Carbon dioxide. Okay, they both give off carbon dioxide. Now we are going to narrate an experiment, okay, to show that carbon dioxide is produced during respiration. So in this case, the aim of the reaction is to show that carbon dioxide is given off during respiration. The materials required are like water, small rats, filter pump, caustic soda solution, tissue funnel, beakers, corks, delivery tubes. Procedure: assemble 3 flags labeled XYZ. Air is drawn into the apparatus using an aspirator. A small rat is placed inside the placed in the jar, which is connected to the setup. Caustic soda is put into the beaker X, which removes carbon dioxide in the air, entering the apparatus. So this is checked by the lime water in the beaker Y. A control experiment is set up with the rats. A control experiment is the experiment set up to standardize what you are having in the real experiment. Okay. Observation: the lime water in flask Z turns milky. Okay. Why does it turn milky? The rats in the setup that is exhaling, okay, releasing carbon dioxide. Carbon dioxide turns lime water milky. So in conclusion, lime water in Z, which turned milky, shows that production of carbon dioxide by the rats during respiration. So we produce carbon dioxide during respiration. A very sensitive part we shall consider is what we call oxygen debt. Oxygen debt. What do we mean by oxygen debt? Sometimes during respiration, cells may need a lot of oxygen very quickly, especially during rigorous exercise. Okay, you will notice that endurance athletes, at a point when they begin to move at the speed where oxygen cannot diffuse. Oxygen is a gas. It diffuses at a very low temperature. So at a very high temperature, it does not diffuse in. So at the speed an endurance athlete is moving, at that speed, oxygen cannot diffuse in, and it creates a situation we call oxygen debt. Okay, because the temperature is high, is too high, which is why at a point an endurance athlete will begin to pant. They begin to breathe with their what? With their mouth. Because that's at that temperature, oxygen can't move in through the nose. So, there is accumulation of what we call lactic acid. Now, the muscles of the legs are using a lot of energy to produce this energy. The mitochondria in the muscles combine oxygen with glucose as fast as they can to make ATP, which will provide the energy for the muscle. But to provide for this extra energy, the cells in the muscle will have to respire anaerobically, because they cannot respire aerobically again. Why? The oxygen required, okay, the oxygen needed by the body or required is not equivalent to the oxygen gotten, and that is the reason why a debt situation is created. That's why we call it oxygen debt. Oxygen is needed to oxidize lactic acid, to pyruvic acid, to carbon dioxide, water, and chemical energy is called oxygen debt. So until lactic acid is used up, breathing rate and heartbeat remain what? It remains fast until so the lactic acid has accumulated in the muscle cells. That's why at the point, if care is not taken, it collapses, okay, or it fades for a while. Then that's why you get what? Glucose D, not food, not rice. That's why an endurance athlete, you don't give them rice, because it will, of any food, because it will go through a whole lot of process before it is digested. But when you give glucose D or glucose solution, so it takes, and then immediately there is no digestion. It will work. It will just be absorbed, and what? Oxidation will begin. Then energy will be generated. So until the cell gets, until lactic energy is what? Is used up, breathing rate and heartbeat remain very fast, and that's why at that point they begin to also do what? Pants. Okay, now this is the table that is talking about differences between photosynthesis and respiration. Photosynthesis and respiration. Now, for photosynthesis, there is something I like you to know, which is why I want to enlarge it for us to see. Okay, for photosynthesis involves, it takes place in the chloroplast of cells. It takes place in the chloroplast of cells. Photosynthesis, sorry about that. Photosynthesis takes place in the chloroplast. Respiration takes place in the mitochondria. Respiration takes place in all living organisms. Photosynthesis, oxygen is given off as what? As byproducts. Respiration, oxygen is absorbed and used up. Oxygen is absorbed, but in photosynthesis, carbon dioxide is absorbed and used up. Carbon dioxide is what is absorbed and used up. Okay, carbon dioxide is liberated in all respiration, but in photosynthesis, water is what? Used as raw material. Okay, in respiration, water is produced, but in photosynthesis, energy in form of heat is what? Is absorbed. Water is produced in respiration. In photosynthesis, water is used up. Sorry, that's the subsequent one. Energy in form of ATP is released. In photosynthesis, energy in form of heat is what? Absorbed. This complementary one for photosynthesis. Apology, and my apologies for that. Water is produced in respiration, but in photosynthesis, water is what? Used up together with carbon dioxide. Okay, should you care to contact us, okay, here is my contact. Thank you. Please do well to subscribe to my channel, okay, Damilare Akilido, where you learn chemistry and biology. We also have another channel where we take self-improvement and moral training, okay, that is for praise educational consultants. You will do well to learn, to subscribe to the channel, also to get more notifications, okay. Spiritual stuff is also being taken on another channel we call Youth Empowerment Ministry. Is the program for Youth Empowerment Ministries with a wide logo. So on this Damilare Akilido channel, we learn chemistry and biology. Please do well to subscribe and tell your colleagues. Thank you.